So for those of you who are late to the beginning, my name is Netta. I'm a data scientist in Crosswise Oracle. Okay, I've been there for a little over 2 years now, and about a year ago we were acquired by Oracle. And today I'm just gonna talk to you guys a little bit about what we do in Crosswise, why we do it, and most importantly, how we do it. Okay, just a sec. Okay, so, wait a sec. Technical problems. Okay, so as you see, most of my lecture is going to be about how we do it, and we have a lot of how, so it's going to be really an overview. I'll take questions at the end, okay, unless it's something really essential that you cannot go on without asking. Okay, so let's just get started. So what we do in Crosswise is we try to identify that multiple devices belong to the same user or to the same person, okay? And the reason we do it, basically, I think that anyone who works at the advertising business or the marketing business can think of a bunch of use cases, but one simple use case could be just think about all the ads that you see on your mobile phone, okay? How many times do you see something that is interesting and then you go home to your desktop and you buy it there, okay? So for advertisers, before we came along, they would not know that the ad to your mobile phone worked, okay? And if we are able to say, okay, listen, this mobile phone actually belongs to the same person as this desktop, then they can know that the ad worked. Okay, so, and this is really just one use case. And how it's done, so obviously this is a long answer, but the short answer is that we process massive amounts of data, okay, on a daily basis and on a weekly basis. And this is just activity data of devices, and Shir gave a little bit of background on this, but I'll go into details. And we process this data and we use machine learning, which we all love, to get insights on this data. Okay, and I just want to say that we have really an amazing dev team, okay, and they do a lot of among other things, they do a lot of the work that involves processing all of this data and doing it in a reasonable amount of time and making sure that we have good access to it, something that is easy and it's quick, and the research team can use it to build our model. Okay, so let's just get started and talk about the model. So this is basically our world, okay? We have either desktops or mobile phones, and those are just nodes, and we want to connect those nodes together if they belong to the same user. Okay, so we have a simple 5-step solution. Okay, first we collect the data, the activity data of the devices. Then we run a local model, a classifier, on pairs of devices. Then we use another model, another classifier, to run a neighborhood model, okay? Again, on pairs of devices, but just taking into account other devices close to them as well. And finally, we use a graph model to go from looking at pairs of devices to actually look at groups of devices, okay? 2, 3, 5, how many devices that you think a person have. And of course, last part is to evaluate what we do and make sure that it's not just random, okay? And I just want to make something clear right now, because I'm going to use this terminology throughout this talk. When I say a device, it could either be like a physical device, like your mobile phone or your desktop, but two devices can also have, like, I refer to two devices also as same physical device, same desktop, but two browsers. Okay, so if you use both Safari and Firefox on your desktop, we will see them, we will see the cookies, and we will say, okay, those are two devices. Okay, so just to be clear about that. Okay, so first step is to collect the data. And this is basically the data that we have is a device, the URL that it's visited, the IPs from which he visited, and the times, which are not in this plot, but also dates and the time of day. Okay, and the first step we do is generate candidates for our model. So again, our model is a classifier that takes two devices and say what is the probability that those two belong to the same user. I'm sorry. So naturally, you would ask, why do you need to decide how to generate candidates? Why not take all pairs of all possible combination of pairs? And that goes back to massive amounts of data. No way of doing it, okay? So we have to think of some way to somehow generate the correct candidates, so to speak. So one naive approach to do that could be just look at the IPs and say, okay, if those three devices share an IP, then I'm going to make candidates out of all of those pairs, okay? And if device 1 and device 4 also share an IP, then I'm going to make a candidate out of this one as well. Okay, so great, we have candidates, and we can now think of features. And we call them pair features, just to make sure that it's clear that we get a pair, two devices, and we're trying to generate features that refer to both of those devices combined, okay? And it could be either desktop to desktop or desktop to mobile, it really doesn't matter. And regarding the features, obviously, I can't give you all of them. But generally speaking, we're talking about the whats, the wheres, and the whens. So the whats are which URLs the device visited, what interests it has, those kind of things. The whens are the dates, the times, part of the day, part of the week, the calendaric day, whatever. And the wheres are things like which IP was it, was the activity from, the state, the country, zip code sometimes, okay? And one simple feature you can think of is just how many IPs the two devices share between them, okay? And again, I can't get into all the details regarding our features, but trust me, there are a lot of features you can create. So we have the features, we have the candidates, and we want to classify. What are we missing? Of course, the labels. So the labels we actually get from our partners, and what we get is simple login data. Okay, so we get that this device and this device logged in using the same username. So a natural thing would be to assume that they belong to the same person. And we get that this device and this device logged in from different users. So naturally, they belong to different persons. And given this label set, we are actually able to run a classifier and move forward. Which classifier to use? So I think Shir said XGBoost, and really XGBoost is super popular, super helpful. It's really good. It really is very good. And it's used in a lot of Kaggle competitions. I bet there's a bunch of blogs and posts about it. So that's what we used up until really recently. And recently, we stumbled upon LightGBM, which is a new framework for gradient descent. And unlike XGBoost, it works leaf-wise. Okay, so it doesn't work level-wise, but rather leaf-wise, which enables it to get to more accuracy in less training time. Or in the same training time, get to more accuracy. Or get to the same accuracy in less, whatever. And this is obviously very good, again, especially when you're working with a lot of data.
I'm sorry, it's production? It's for data scientists.
What?
It's production or it's data scientists?
We use it in production. But we have an amazing dev team, and maybe they did some magic. So the danger about LightGBM, because it works leaf-wise rather than level-wise, is overfitting. So for overfit, just like in XGBoost, we have a lot of parameters that we can tune. But if I can give you, like, our advice from what we saw, is that here you have to be much more careful for overfit. Okay, so you have the number of leaf, the mean data in a leaf, max depth, they will all work. And if you want to speed things up, then of course you have, again, everything has a parallel in XGBoost, or almost everything has a parallel parameter in XGBoost. And of course, there are a bunch of other parameters, but I just can't get into it. So we train the model, and it works. Great, we get predictions. And so for each pairs of devices that were in our candidate set, I now have the probability that they belong to the same person, which is nice. And theoretically, we could have stopped here. But we can do better. So one way to do better is look at the neighborhood of the devices. So let's say I'm looking at those two devices, and they have a pretty strong relationship, 0.9, right? But I can look at things like the number of alternative paths to get from this device to this device. Like in this case, there's one alternative path, right? And I can look at things like, what is the rank for this device and for this device? Okay, so for 0.9, it's ranked first for both of them. But for example, in this device, you'd see that this is ranked first for this, but ranked second for this device. Okay, so we can generate a bunch of features like that. And we train another model, again, a classifier. Okay, and we just update the scores. And it's used with this. We generate the training set in the same way, but it's a different training set. Okay, and that's to avoid the leakage that Shir mentioned as well. So we'll train this neighborhood model, and we'll update some scores. Let's say that we updated only this. And this is great. And again, we can stop here. But what's our problem with this solution is that we give it, we're still talking on a local, we're still talking on pairs of devices. Okay, so I can say this one and this one, device A and device B belong to the same person, and device B and device C belong to the same person. But then I may say that device A and device C do not belong to the same person, and this kind of sounds fishy. So what we need is just another model, a graph model, okay, where we actually want to create communities and say that groups of devices all belong to the same community, community being the same user. And if we want to define community, a very natural definition would be groups of nodes that are internally connected and loosely connected to other communities. Okay, so this is what we aim to do. And in this case, I think most of us would agree that there's at least two communities here, right? Some of you may say, no, this one should be its own community, but at least two communities, right? So this is great, but we can't go over our entire graph and say, this one looks like a community. And so we need to decide what to do. So first, let's say that we did have a community. We have some magic algorithm that says, OK, those one are connected, and those are all connected. So what we would want to do after we have the communities is remove the edges between communities and connect all internal edges within a community, right? Just given that we have a community, the edges that connect different communities will be removed. Okay, I don't want, if we had something to partition. And this is really our next slide. How do we get this partition? And so we get to yet another subject that I could do a complete talk about if I had the time, which is community detection algorithms. So community detection algorithms is really a growing field right now. There's a lot of paper on it, a lot of research on it. And in my opinion, the nice thing about it is that a lot of research comes from different fields. So you get a lot of different perspectives of the problem, a lot of different solutions. It's really useful for social media graphs, obviously. Biology networks, which I have no idea what they mean, but I guess some of you do. And citation graphs, all kinds of things like that. And it so happened that it really worked well for our problem as well. So we did some research about it. We did some reading groups about it. Yuval, who is sitting here and was leading this project, found a bunch of things that looked interesting. We looked at Luvine for a while. It was used in a lot of places and seemed to have good results. But what we ended up using is InfoMap, and specifically its parallel implementation, which is called RelaxMap. Okay, so basically you start with each device as its own community. Okay, and you at each step you get to a specific node, to a specific device, and you can decide on one of three things. Either you add this device or this device to a specific community, or you leave it in its current community, or you start a whole new community with it. Okay, and we iterated over for a while. In the original implementation in InfoMap and as well as in RelaxMap, they try to minimize the map equation. Okay, in our implementation, we used a slightly different optimization goal. simply because it worked better for our needs. And we also have an undirected graph because two devices belong to the same user in both ways, okay? So we also did some adjustments there. And we used relaxed map, which is the parallel parallel generalization, which is better, again, because we have all this data. And that's about it. Or I could, again, that's about it for the time we have. And so we have, finally, our final goal. We have communities which are completely connected among themselves and are unconnected to any of the other communities. Okay? And as I said, the last but not least, we have to evaluate what we do. And this is where we go back to our labels. Again, do not use the same training set that you used in any of the models. We have our validation set, we have the yes pairs and the no pairs, and we use precision and recall, which I'm going to assume that you all know, but just in case we have the lovely confusion metrics here. And of course, there's a trade-off between them. Okay, so usually, unless I am able to take my entire curve upwards, I'm going to have to either give in on precision or on recall. And obviously, if you want more scale, you'll have more recall but less precision. But if you want to really be sure of yourself, then you go ahead and lose some scale. And in our case, we care a lot about scale because the ad business just works like that. They don't mind showing ads to the wrong people as long as they do not miss the right people, okay, obviously. But again, it really depends on your problem that you're trying to solve. I should mention that it's not that easy for us because our label set, for many different reasons, which again, we do not have time to get into, is very biased, okay? So first, you need to remember that at the back of your head, and then you need to start thinking of how to account for that bias. Maybe you can change it when you're training. Maybe you should just, when you're evaluating, you should just fix the evaluation in some way, just give weights, higher weights to examples that look more like the real world, okay? Stuff like that. And this is actually something that we are dealing a lot of our research focuses on how to measure, what to measure, and why to measure everything, okay? Something else that we look at and is not in this precision recall trade-off is the stability of our solution, okay? Because we give our clients a new batch of a new solution every week, but we can't tell them in week 1 that device A and device B are definitely the same person, and then the week after say, no, actually, this is John and this is Jenny, and then the third week say, no, scratch that, they are the same person. So we need a measurement for stability, and we also need to make sure that our solution is fairly stable. Okay, and again, this is still an open research subject for us. We are working on it a lot, and it's really interesting. And well, this is pretty much everything that we've done so far. But in the last year or so, since we were acquired by Oracle, we started working with other startup companies that Oracle acquired and are part of our cloud in Oracle, the Oracle Data Cloud. So we got a bunch of new data, which all data scientists love. So we have names and email addresses and physical addresses and telephone numbers, and you can think of smart TVs and PlayStation devices and all of those stuff. So you get a much bigger graph with different types of nodes. None of these nodes is 100% unique, okay? You can have two people with the same name. You can have two people sharing an email or an office email or stuff like that. Really nothing, I think, is obviously two people living in the same house if they're married or just roommates. And people always lie. So basically, you'll get a bunch of names like Donald J. Trump or emails like blah, blah, blah @com. So we need to account for those. And there are things that are really straightforward, like blah, blah, blah @gmail.com. But some people lie more sophisticatedly, so to speak. So you need to think of what you do with those stuff. And well, now that we have this offline data, we need to think of how can we connect offline entities to online entities? And this is really a big question and an open question for us. And it's really, really interesting and really useful. Because even though people buy more and more stuff online, which is what we solve, people still buy offline stuff, especially big stuff. Okay, I don't think anyone bought a car from his mobile phone, right? Or a house, or I don't know, stuff like that. So here there is really an opportunity to connect the offline and online, and it's super interesting. And we have missing data. The missing is not happening in random because that would be too easy, obviously. And really a bunch of open questions, but we have a lot of data and we have a lot of time. So if you have the answers, you can just come pick me in the end and tell me all the answers. That will be fine. But if you're interested in finding those answers, then we're always hiring, and we would love to have you. That's it. Yeah.
I have a question. Let's say about what, where, and when.
Yeah.
Let's say in my work and in my home, I have different IPs, even countries.
Right.
And let's say the content is also different. Let's say at work, I am looking to algorithms. At my home, I read about poetry. Let's say this approach will connect.
So, of course, this is a hard example for our algorithm to learn. There are still stuff, because you tend to think that you do completely different things. But, I mean, how many times did you read a paper at home? You do that. You don't read it just at work, right? And how many times were you in a site that is not completely work-related during your working hours? Just once. Yeah, but we don't have login information of emails and Facebook. It's not small. It's relatively to the... So we get it from our partners. Sometimes it's actually our customers. But it's really small compared to the entire data set, obviously. It's not small like 70K, but it's small compared to the... Yeah, so I'm going to tell you the honest. So honestly, I am not a developer. But as I said, and I didn't just say it to say it, we do have an amazing dev team. And they do a bunch of things that for me are magic. Honestly, I have no idea what I'm doing. It's just like, it's working. And I have easy access to everything I need. Most of the time. Yeah.
I wanted to ask, you said your data is biased, so I wanted to ask why and how?
Our label data is biased, and it's just a simple example could be that we get login data, right? But there are people who are really private, and they do not log in from any computer other than their own, and they will never log in from their mobile phone because maybe it would. And there are people who just do not buy things online, so they don't have logins for anything. So these are kind of things that we may miss in our label data.
And how do you account for that?
Yeah, so there's a bunch of things. Basically, a lot of the time, a lot of what we did was just trying to estimate how biased are things during the evaluation. Just you have the features distribution, right? So you can see which labels look more like the real world and just give them more weight, either during training or during evaluation. You can think of it like as upsampling the samples, the labels that do look like the real world.
You're trying to understand which samples are more similar to the real world.
Right.
And take them.
Yeah.
Follow up on that, and then on what you said earlier, that models should be many times judged by their drawbacks. Suppose I'm a person who does not, I care about my privacy. I don't want to give corporations the data and power to control what I want and what I buy. What would you recommend me to do so I wouldn't be classified?
So there's the opt-out option. I am not sure how you do it as a consumer, as a customer, but I know.
What kind of data would make your algorithms show?
I can't tell you really what is the best. I can tell you that for now you're safe because we're only operating on the US. But you can opt out and just ask not to be added to anything somehow. I don't know how, because I know we take the opt-outs out because we can't do anything with them. Any other questions? Cool. Thank you.